Hello, everyone. I'm Nitzan Shapira. I'm one of the founders and the CEO of Epsagon. And I'm going to talk about, error handling and how do you troubleshoot applications in this kind of new environments in the cloud. Serverless is obviously one of them. And with some examples, some techniques, hopefully things that you can actually use. About me a little bit, so I'm based in Tel Aviv. I'm a software engineer in my background. I've been doing software for about 13 years as a developer. I managed several teams. I did a lot of stuff in the cybersecurity space, reverse engineering, embedded systems, infrastructure-related stuff. And in the past 2 years, I'm one of the founders and the CEO of Epsagon. So just really quickly, what we do, essentially, we provide this kind of distributed tracing for cloud applications, serverless as well. So basically being able to understand what's going on in your production when you have these kind of applications. And I'm going to go into it as we talk. So we're going to talk about, how is serverless different than traditional applications and what you should be thinking about when you develop and operate these applications. And then, stateless is you know what stateless is, but why is it important? Because many applications today have stateless components, and you have to be aware of it if you want to troubleshoot problems efficiently. And then different techniques to handling problems in such environments, and hopefully you can take away some of the things to your job and have a better life when you troubleshoot these complex applications. So serverless, in the broader sense, is the concept of running software without managing infrastructure. And the way to do it is by using services to run your code and to utilize many external services, APIs, AWS services, or another cloud provider services, or just any API in the internet to do what you need. And as Eric Peterson said before, so serverless is not just functions. Everyone that starts to do serverless sees that you connect those things together, and then you end up with a serverless application. That function as a service is just one of the things that comprises it. And eventually, you want to focus on your business logic. You want to go to market faster. Pretty simple. And of course, the financial benefits are important, but more than anything else, you want to ship features faster. You want to get better customer experience for customers. And that's like the really main benefit of going serverless as a concept, not just using Lambda or anything. Just basically you want your developers to run faster. Now serverless and specifically function as a service have different limitations. So some of you of course know about limited memory, limited running time, cold starts, and other things as well. But stateless, the one I'm going to talk about, is not exactly a limitation. It's by design. These functions are waking up and then they die because this is what they do. But you have to be aware of it because you have to use them in a context. They don't work alone. So stateless, what does it really mean? It means that you can't do everything that you want in the function. The function is very limited, so you utilize more and more APIs. And serverless applications use more APIs than ever before, both stuff like DynamoDB or S3 here, or anything like Stripe or Slack, because you can't really write a lot of code in a function, so you use more and more stuff that's already out there. And what happens is that you split your application into smaller pieces, and you end up with very distributed application that is also event-driven. So one event will trigger another event, and so on, as you probably experienced, some of you, which creates complexity and challenge. And what I mean by highly distributed is that basically you can end up with hundreds of functions. And think about the graph that you get. It is pretty complicated. And utilizing APIs is not optional, it's actually necessary, because this is how the functions connect to each other by an SNS, or just using Auth0 to authenticate the user. APIs are a crucial part of the system. This is just an example from the last re:Invent, a pretty complicated architecture by HSBC that it's not just an example, it's something running in production. So companies are doing it all the time. It's not the extreme case. This is actually the common case when you grow a little bit. And of course, the challenge that I'm talking about is just the natural challenge of complexity. You take something simple, you make it more complex on the design, the software design level. So obviously, it's more challenging to troubleshoot and to monitor this kind of thing. So it's not, nobody should be surprised. I mean, if you if you have a complex software design, you should have the right tools to understand, to help you understand what's going on. And when troubleshooting something like this, most people still think in the old way. So I have a problem in this function. OK, let's see the logs and the metrics and what's going on in my function. But actually, there are 5 other functions involved in this event or series of events. And the ability to connect them together is what will actually help you understand what's going on. So using logs is OK if you have something very simple or function metrics. But once you go beyond 10, 20, 50, 500 functions, you really need to connect it all together. And even the community agrees that debugging and monitoring are the top 2 problems in serverless this year and the year before. It's not a surprise. People are only building more complex stuff in serverless. So let's talk a little bit about error handling or troubleshooting or whatever you choose to call it. So how do people used to do it in the past? So when I mean traditional environments, I mean server-based applications, an application that's running on a server. So usually you have a log, right? You are a developer, you write a log, the log is being saved somewhere, and you know that if something goes wrong, you go to the log, and in many cases it will tell you the story of what's going on. You can even sometimes connect to the host, you can run a debugger, you can do a lot of stuff, which if the application is this kind of application, that's enough. Maybe that's good enough for you. And another thing that people use a lot is agents. So probably you know about application performance monitoring tools that use agents. So the agent will be installed on the host, on multiple hosts. It will run 24/7, collect metrics, instrument code, instrument frameworks, and basically provide you with metrics about the infrastructure and the application that you can later monitor, get alerts based on. Pretty useful, very easy, pretty automatic. But you need to have a host. You need to have a state that the agent will run on. So you cannot really do much without a host. So of course, in functions, this doesn't apply anymore. And as you know, event-driven, no server, no state, you cannot really use a log, you cannot really use an agent. You get logs from the cloud provider, but there are so many of them. I mean, every invocation, you get another log. Now you got a billion invocations, so you have all those logs, no context, no connection. It's just not the right tool, and everyone feels it right away. By the way, we are fully serverless in our company. We have close to 1,000 Lambda functions, and after like 10 or something, we just started to use our own tool because it was not practical to use only logs. You just need something more suitable for these kind of applications. And basically, in addition to the fact that you cannot run an agent, the function cannot store anything, so you have to send everything right away. You cannot store it, compress it, do these kind of optimizations that will help you improve performance. So how do you do everything without impacting performance as well? So what types of error handling mechanisms are there? First of all, what types of errors, right? You have an exception in the code, a problem that is in your own code. You get an exception. Everyone knows this type of problem. In serverless, you get also timeouts, out of memories, new types of problems that didn't exist before. And they happen all the time, and you need to do something about them. So in order to deal with it in some way, the cloud providers chose to implement a retry mechanism. And we can also implement it ourselves in our code. So retry means that if something fails, we do it again. Obviously, it sounds good because, why not? We can retry. But as you know, it doesn't always work. So for example, if I'm running the code and I'm calling an API and it fails, I can choose to retry it 1 time, 2 times. It's up to me. I can do it, I don't know, like up to 5 times, and that's it. That's up to me. But sometimes it's actually not up to me. So for example, if an SNS is triggering a Lambda, by default, the Lambda will be running more times, up to 3 more times, according to the period of time that's been since the initial request. So many people actually don't know it, or even if they know it, they have a really big mess kind of following of what's going on there. So that's one example. And if you have a kinesis, a stream-based event, it's being triggered again and again until the data is expired. So AWS will try to process the data in any case until it's been too long and the data is not relevant. So these things, this is a proper technique. Sometimes it's good, but sometimes it actually doesn't make sense. Do you really want to do everything more than once? Sometimes it has an impact. And for example, when troubleshooting something, people have a lot of trouble because, well, troubleshooting with trouble. But sometimes they kind of take a look at the log, but they don't know that there was a retry. So one of the things that we do is basically we say, oh, this Lambda was invoked 2 times, and we connect it for you, so you don't have to waste time. So you know that this was a retry invocation, just for example. Now think about the impact of retry. So if your code is being run more than once, of course it changes something in the application. It does some logical behavior that may or may not have an impact on the application. Maybe it will even make the application not correct anymore. So actually, if you really want to live with the retries in happiness, you need to design something that's called idempotent applications. What does it mean? According to Wikipedia, it's a property of certain operations in mathematics and computer science. They can be applied multiple times without changing the result beyond the initial operations. So it sounds pretty complicated, and if you think about your own code, if this applies to your code, probably not in most cases, but your code is being retried. So actually, it's wrong. It's a bug. Like if your code is running more than once and doesn't have this property, there's a problem. An example of a code that does that, so if you update the same DB entry twice, that's fine. You can do it again and again, of course. If you authenticate a user, you can authenticate them 5 times. They will be authenticated. It's fine. Or if you want to look if a file exists, if not, you create an empty file. These are good examples for idempotent operations. But if you think about your functions, are they like this? Well, you don't even know. I mean, you have to think about it, and you have to think about designing an application like that. You have to design a pretty complex, state machine. How are you supposed to think about all the possible scenarios? So honestly, my opinion is that it's not really practical to design this kind of applications. People will eventually make a mistake, and then that's it. So what do you do, right? So you have services for that. So step functions is a good service. It's an orchestration service that allows you to connect pieces of code with conditions and basically control the flow of your code and have all the retries built in. So if you use step functions, it is more likely that you will create an application that will survive this kind of retries. And this is the way it looks like in AWS. It's a pretty nice service. Of course, it's a bit complicated to deploy. This is an example with Serverless Framework. So you need to kind of describe all the different functions, how they are connected, all the conditions, and so on. But it's possible. And of course, observability is still challenging. What's going on in the step functions, you still need the proper tools. It's not going to be, nothing is going to solve that for you. So this is an example. So you can see many functions calling one another. Now, if you think about general serverless applications and error handling and troubleshooting, what do you really need? I mean, retries, okay, you want to be ready for the retries. You want to think about it in advance. You want to monitor them. What else? So eventually, you want to monitor your functions, probably, right? You want to monitor function metrics, errors, and so on. But is it enough? So it's important because many functions have problems, and you want to identify these problems. Pretty straightforward. But the fact is that if you look at this picture, this is not just functions. There are a lot of things that connect the functions, which is why serverless is not just functions, as was mentioned before today. So what do we really need? What will help us understand what's going on there? Well, basically, if you want something that you can describe in words, is asynchronous transactions. So function calling another function, triggering another function. This is something that will really help you understand what's going on and eventually avoid this kind of scenarios, that using log for a distributed system, which is not the right tool. And if we want to trace asynchronous invocations, what does it mean? So if we have a function, we want to be able to know what functions are triggered from the first function and then triggered after the second function, third function, so on. So connect those function invocations together. And also, we cannot forget about those APIs that we're using. Some of them are not part of the cloud provider, but they have a big impact on our application. They can cause timeouts. They can cause performance issues. Usually, the external APIs are going to be much, much slower than cloud provider APIs, and I'm going to show an example later. So you want to really make sure that the performance of these APIs does not impact your application. You're also paying for every call, of course, because it's pay-per-use, so you wait, you pay. So how do you achieve this? So there are different techniques. Generally, this whole field is called distributed tracing. So it's not something, I didn't make it up. It's something that's been around for a while, but it's still not common in distributed applications. Usually a distributed tracing solution is not implemented yet today because people have been doing microservices for several years, and serverless is kind of much more distributed, and then people see that, okay, we can't really use logs anymore for these things. And what we talk about is essentially to be able to tell the story of a trace that goes into the system and goes through multiple services until it ends. And it can tell the story of a user request. It can be used for troubleshooting, for monitoring, based on the connections between the different services and how they talk to each other. And this is an example for a tool called Yager. It's an open source tool. So if you have the distributed tracing data, if it's connected, you can pretty much put it inside Yager, and then you get a picture of those waterfall. You see the call between the services, the performance, and so on. But how do you even get the data in the first place? That's eventually the big challenge, because every function is being run individually, independently, but they are connected logically. So there are different ways to do it, and I'm going to talk about ways to do it without using an agent, because as mentioned, we cannot install anything on the host. It's just a Lambda function, for example. So the two most popular frameworks for tracing are OpenTracing and OpenCensus. Generally, it's pretty useful, pretty easy, very well documented, and you need to implement it in your code. So it can be implemented in functions, in containers, any kind of distributed system. You can basically use these frameworks to tell what's going on. So when a service talks to another service, you need to put this piece of code in your code and tell, okay, this was a trace. Now think about, it's good, it works. There is a lot of work, a lot of maintenance, and potential of errors, of course, because it's manual work. But this is one option. Now think about serverless in general. So people use OpenTracing for microservices. So you maybe have 10, 20, 30. But in serverless, you have hundreds, even thousands of functions. And does it make sense for every developer to go inside the code and change and add these things as they go? Eventually you want developer velocity. That's the whole point of doing serverless. So you kind of say, okay, I'm going fast, slow down. We have no idea what's going on. Let's do this thing and then continue and then go back. And eventually you're going to waste a lot of time. And when I mean distributed, this is an example from our backend. So this is pretty complicated to understand what's going on there. And imagine going one by one and just putting the function there. So you can see here Stripe, Slack, or Zero somewhere. So it's very distributed. It's not just 5 services talking to one another. This is hundreds of functions. So what can we do to make it automatic? Eventually, well, the answer is automation. So if we could do it automatically, we could say that we enjoy both worlds. We can work fast, the developers can run and iterate and develop new stuff, and there is some tool that does that automatically for us. So what I'm trying to say is that if you're doing serverless, you should think about automation as it's not optional. If you don't do automation for your monitoring, for your tracing, you're gonna waste a lot of time, and then you don't enjoy the main benefit of serverless, because you get to complexity, and then you have to write a lot of code to help you understand what's going on. So automation is actually critical. And an example for one of the things that you would want to get when troubleshooting a problem is say, okay, the function failed. What was the exception, of course? What was the log of the function? What was the payload in the SNS to understand, what was the input? And what happened in this function? What was the log of that function in the context of the transaction? Not just any log, specific log. And even go to the Auth0 API to see that it actually failed to authenticate. And the API gateway, you can see what was the user. So all the data that you need automatically traced. So then you can, when something goes wrong, you go there and take a look. But you don't have to manually do it as you go, because otherwise you're going to waste a lot of time implementing solutions in your code to help you understand what's going on. And one example for why you should care about all those external APIs is that in this example, the Auth0 call takes about 700 milliseconds, and the SNS is much less. So the impact is significant. It's not just a little bit more. And I actually took this morning a screenshot for our system on our own backend, and how much time do APIs take. So I just picked randomly some services from AWS, some services outside, and looked that Stripe is doing 200 milliseconds, Slack 500, but DynamoDB and Kinesis are like 10x less. So you're spending 90% of your time possibly doing API calls to services that are, outside of there compared to the AWS services. So, if you just switch from one service to another, you might be improving the performance significantly. You might be avoiding timeouts. You might be saving money because you're paying for this stuff. So just something that you want to monitor and be aware of. And one last thing that I'm going to mention is the tracing and the logging. Usually there are two separate things. Developers are used to work with logs and operations, one tracing and monitoring and metrics. But if you think about it today in serverless, there is not really a separation between operations and dev. The developers are involved in everything, sometimes with DevOps and so on, but everyone really needs access to both logging and tracing. So thinking about them separately, it's something that actually, in my opinion, doesn't make sense anymore, and we need a solution that combines them both. And if you could actually have the data in one place, have the distributed tracing connected with all the payloads, with all the logs, and it can be searchable, so you can actually find any piece of data in your system. Everything that happens, you go there, and you solve it in minutes instead of hours or even days. And the fact that you can go and get a trace, distributed trace, and see the logs, so you see the log of the function, is something that's basically saving you a lot of time and connects all the dots for you. And searching, when I mean searching, it's textual searching, so you want to be able to search in logs, something that is pretty difficult. That's why many people stream CloudWatch logs to stuff like Elastic, so they can search, but you also want to be able to search in the right context. So you want to get logs like traces based on a certain business flow or a certain API call is being called, not just text to a log, because not everything is written to the logs. You want to combine traces and logging in one place, and then you know what you're looking for. So this is where you're going to find it. And just to finish, first of all, I really recommend you to use serverless. I mean, we are doing it not because we have to, but I mean, we were probably 400 functions a few months ago. Now we are at 800 functions because it's just really good. I mean, we just keep developing in serverless because it just works faster. But you have to think about the fact that it's not just functions. It's an event-driven architectures. And once it goes beyond a certain limit, you will find yourself spending either a lot of time implementing solutions to help you understand what's going on, or searching for a solution that will help you do it. In most cases, some cases people are lucky and they have very specific types of architectures, but in most cases it's going to be very event-driven. And using orchestration services can really help you, like step functions. And very important, automate. Automate as much as you can, not just observability, but CI/CD, testing, even security can be automated. Because eventually your developers are going to be spending time doing these things if you're not automating them. And this will allow you to go to market faster. Thank you.